Hi, I'm Mike with Electric Lab. Today, this teaching is on the subject of programmable logic controllers. And this is all coming from our student lab book, Programmable Control Systems Basics. Now, I want to start out by saying this is a teaching and system of training for PLCs designed for the electrician. Now, those who are looking to get into engineering certainly would benefit from this, but what the teaching that we are providing is predominantly designed for those who are actually the installers of the electrical systems and installers of the wiring that goes to these types of devices. So some of the subject that we'll cover in this will be just an introduction to automation in general, PLC hardware and software, and then some programming basics, and then wiring. So this first section will really cover the foundation of it, give you a little bit of background where it came from, and then we'll move on later into the hard wiring part of it. So let's get started. Okay, so Programmable Control Systems Basics. This presentation is based on the Automation Direct Koyo Click Series PLC and the EL430 or ELPLC control trainers from Electric Lab. And this brand of PLC was chosen because it is, from what I have seen, one of the most user-friendly and learner-friendly PLCs on the market. And we'll see before it's over with, the software actually can be gotten from Automation Direct for free. There's not a charge for it. And the PLCs are, well, we'll call them reasonably priced. Now, the origin of the programmable controller, and that picture is the Modicon, the original first PLC. Programmable controllers, or PLCs, are industrial computers that control machines and other industrial applications, along with such processes as a car wash or stoplights at a roadway intersection. Today, they are a part of such processes as HVAC control systems, bakeries, and other food production, like donuts. In 1968, engineers at the Hydromatic Division of General Motors Corporation wanted to take advantage of computers on the factory floor. Their goal was to reduce the high cost and time required to replace relay-based machine control systems. Dick Morley and his company Modicon began manufacturing and selling the Modicon 084. It was presented to GM to be used as a standard machine controller. Eventually, they would make the Modicon 184, which changed the industry forever. It was a tremendous success, and the programmable controller known as Modicon was what revolutionized manufacturing as we know it today. Now, PLC hardware. Different options are available for connecting input and output modules to the central processing unit. Some are fixed with a specific amount of I/O or inputs and outputs, and some have a stackable design where I/O cartridges can be added to create more ability to control systems. And what you see here in the picture is a standard click PLC, which is likely the one that's on your trainers if you have an Electric Lab trainer. And then the one next to it, that is the power supply, and then a click PLC like you see. And then each one of those, we'll call them cartridges, that snap on there could be adding more inputs or more outputs to that entire PLC block. Although there are many types of I/O, they all can be classified as analog, discrete, or specialty I/O. Discrete I/O is the simplest type and provides the PLC with an on or off control. So first, the power supply. The PLC will require a power supply. It can be a part of the base or a separate unit. Voltage ranges available may vary. Often the primary power incoming is 120 volts and the secondary side will be 24 volts, which likely the equipment you're using, that's exactly what you're looking at. And you can tell on the terminals on this power supply where power's coming in on the line side, and you have your line, and then of course your neutral, of course your equipment ground, and then on the load side on this particular one, it has a 24 volt power supply coming out, and that actually is the conductors that jump from there over to the PLC itself to power the brain of the PLC. And I should back up by saying the central processing unit, or CPU, that is the brain of the PLC itself. The central processing unit, or CPU, contains a microprocessor, memory storage, and electronic circuitry to provide the control system, house logic, data, and to be the intersection of communication for external devices such as switches, sensors, coils, indicator lights, etc. And essentially what you see in the picture right here is what you need to make a PLC work. You got to have the PLC, that would be on the left, and then you need to have some sort of communication device, in other words, a laptop or computer on the right. And then you have in the middle there a communication cable. There's a few different types you can go to in that respect. The one that we are using is the one that you see in front of you there. Mounting. So installation and mounting of the PLC unit can be done by direct securement to a surface or by using DIN rail. And as you can see in the picture here, this one is mounted on a piece of DIN rail. The power supply units often mount in the same manner. So what you see, and again, I'm sure this is what's on your trainer, is you have the power supply there to the left, and then the PLC itself just literally snaps onto the power supply like a Lego. And then you do have to run wiring from that point to the PLC. If you had other input and output cartridges you were adding on to that, they actually electronically connect as you snap them together. And then they have a small sliding lock on the top and bottom that holds them together. Now, PLC software. And this is an example right here. So I'll stop and say this. I would assume if you're in this, more than likely you have been through our electrical control systems material, and perhaps actually went through the wiring scenarios that were with our EL360 or EL430 control trainers, and you have a base knowledge of hard wiring systems for control. This is really what I would call the advanced or next level. There are many brands available today, and each have their own design in regard to basic navigation, addressing, terminology, and functionality. The specific need in the control process will often dictate the type to be used. And the one in the background picture there, that is a classic version of the Allen Bradley PLC. Ladder logic is still the primary programming language in the PLC used as the basis for learning in this book. The Koyo Click Series PLC has one of the most user-friendly program softwares on the market. Understanding PLC ladder logic. So, the transition from hardwired systems to PLC ladder logic has two core points to contend with: what is occurring in the program and what is occurring in the actual hardwired process. Or a better way to put it, what is virtual and what is physical. You can see that up here where this square is, that is the X004, that's the input, that's a switch, it's a momentary contact, it's a selector switch, whatever the case may be. And then here is the output, which is a timer. This timer is all inside of that PLC. If you were using one of our EL430 trainers, that has 4 timers on it. The PLC that you're using has the ability to have 100 timers. So in other words, you could have some sort of a program that's cascading through various timer sequences to make a sequence of operation occur. The T9, that is the output. The T10 on this particular timer, it has a reset to where when the program rides back up to the T10, then it will reset this timer and make it run again. For example, a program might start with the press of a push button, and then other inputs that are internal to the program may react. This is called an internal bit. The logic shown above is a PLC version of what is known as a seal-in circuit. Again, assuming you have the experience previous to this teaching in control systems, you should very well know what a seal-in locking or latching circuit is. When X001 is pressed and then released, output Y001 is energized. When this happens, the seal-in contacts with the address Y001 will remain energized, causing the seal-in effect and maintain the Y001 output in the energized state until X001 stop is pressed, releasing the seal-in. So in other words, that That set of contacts that is the seal-in in that circuit is actually a virtual set of contacts. Addresses, inputs and outputs. And we have some symbols here showing that. The start button, that's obviously an input. Y002 in the middle of our screen, that's your indicator lamp, for example. That's the output. And then, of course, on the right, there's a timer. So great examples in this slide. Ladder logic is based on electrical diagrams that were used with relay logic. They depict how devices are connected in relay panels. Ladder logic was designed so the adaptation from hardwired systems to PLCs would be easier to understand. The main exception is that ladder logic has physical contacts and coils are replaced with memory bits. The language depends on the brand, and it may be a combination of numbers, letters, and abbreviations. And I have just a few examples of brands, you might say, that are shown on the screen here. And I believe that as you go through this teaching, you will begin to develop an understanding of how ladder logic works when it comes to the PLC. And then if you were to begin to work in an environment where maybe they weren't using the Click PLC, they're using Allen Bradley or Siemens or another brand, you at least would have a base knowledge to where you could adapt to whatever language is used for that brand. So, the core input and output addresses are shown below for the Koyo Click PLC. So the X001, all inputs will start with an X and include 2 zeros and then the indicating number of the address. So example would be X001, X002, X003, etc. Y001, all outputs, including timers, counters, etc., will start with a Y and include 2 zeros and then the indicating number of the address. Y001, 002, and 003. And then timers, or T1 for example, all timers will start with a T and include a number indicating the address of the timer itself and its output. T1, T2, T3, so on and so forth. And then CT1 is a counter, and it will have the letters CT and include a number indicating the address of the counter itself and its output. The Click PLC software requires the use of an end instruction at the last rung of all programs. This must be placed at the final rung to a program, or the program will not be allowed to be downloaded. Once all input and output programming is in place, click on the end instruction located at the right of the screen under the heading Program Control. Basic input and output instructions defined. There are many different types of inputs and outputs. We will address the foundational types only in this curriculum. And I will stop and say that, yes, this training is core principles, core operations of the Click PLC, and the very basics of making a PLC operate. There are many other features, just like my iPhone has many other features that I will likely never use, but the PLC is just like that. We'll get you to the point where you can create programs and be able to create scenarios where you can use this type of equipment because you have the base knowledge to do it. I/O defined. Inputs. Inputs can be normally open or normally closed and be in the form of a push button, limit switch, sensor, pressure switch, selector switch, and more. Inputs can be all over the place. When you get to the point where you're really getting into inputs is a whole nother subject, to be honest with you. You have motion sensors and presence sensors, and there's just lots of different types of sensors out there to be used. Outputs can be in the form of an indicator lamp, coil in a relay, coil in a timer, counter, or solenoid controlling a pneumatic cylinder. And timing. Timer instructions are available to allow for on-delayed or off-delayed events. Once triggered, the timer will turn its associated output on, that would be on delay, or off, that would be off delay, after the set time has elapsed. And counting. This is an interesting one. Count up and count down functions increase or decrease the counter value on every actuation of the input. This could be used in counting soft drink cans in a manufacturing process. For example, once a case of 12 cans is passed by the counter, the process closes the case and starts a new container box. And set and reset. This is really a version of a seal-in. The set instruction turns on the associated output device when the status of the rung is energized. This output device stays on after the rung is de-energized. The reset instruction turns off the associated output device when the status of the rung is energized. The output device stays off after the rung is de-energized.